Greetings, A-level chemists. Okay, here we've got an electrochemistry question. Now, AQA isn't really that big on electrochemistry. What I've done is I've had a look at all the electrochemistry questions from 2015 onwards, and there aren't that many of them, and there's no common theme. But OCRA and Edexcel are quite big on electrochemistry, so let's do it. So from the table, you have to draw a labeled diagram of 1 and 4 being connected in an electrochemical cell, and we have to draw a label diagram of how we do this in the lab. Okay, cool. So we've got a beaker. We're going to have some chromium metal in a solution of its ions. And the solution of its ions is chromium 3 plus AQ. And I'm just going to put down that should be 1 mole per decimeter cubed for standard conditions. My God, that looks so wonky. Oh well. Right, we're going to connect it to a high resistance voltmeter, so we don't want any current flow because that's going to affect the voltage reading that we get. Then in our second beaker, we're comparing it to the manganate Mn2 plus half cell, okay? Now, that is a reaction which is occurring in solution, so we need a solid surface for that reaction to actually occur on, and what we're going to do is we're going to use a platinum electrode, okay? And that's going to form the basis of the surface of that reaction. So this is a platinum electrode. You have to use platinum electrodes for half equations which are in solution where you don't have a solid involved. Okay, and then what are we actually going to have in our pot? So we've got our platinum, so that's the surface for the electrons to form on. We've got some Mn2 plus AQ. We've got some MnO4 minus AQ, and we also need some H plus AQ, and the solution concentrations are going to be 1 mole per dm cubed for standard conditions, okay? Now, we need something connecting these 2 points. And what structure connects 2 points together? It is a bridge. And in this bridge, there's going to be some salt dissolved in it. So the name of this structure is going to be called a salt bridge. So, a salt bridge means that the current can continue flowing and it completes the cell. And you normally have some sort of salt in there. I wouldn't use KCl, I'd use something like KNO3. And the reason for that is a chloride ion could be oxidized by a really strong oxidizing agent. Likelihood is that the nitrate ion is not going to be as easily oxidized, okay? So, if you want another follow-up video on how a salt bridge actually works, put it in the comments and we'll do that for you. If you're enjoying this content, please subscribe to my channel and click the link in my description to sign up to my course.